So in this case, one other thing that you'll see as we move along in this unit, looking at applications of electron transfer, is a lot of times also we'll write reduction reactions as two half reactions. One half reaction is the oxidation reaction, the other half reaction is the reduction reaction. And again, there's reasons why we do that, and we'll get into it further, but for now you just need to recognize that we can write an oxidation half reaction and a reduction half reaction. And when you add them up, the two halves, it makes a whole redox reaction, or you can look at them separately if you're trying to make a point. So for example, in this particular chemical change, platinum ion plus hydrogen to give platinum 2+ ion plus hydrogen ion, you want to first, if you want to identify the half reactions, you have to first identify what's undergoing oxidation and what's undergoing reduction. In this case, the platinum is going from +4 to +2, so that must be a gain of electrons, so that must be undergoing reduction. And the hydrogen is going from a 0 oxidation state to a +1, so that must be a loss of electrons. Okay, so a loss of electron indicates oxidation. All right, so if I want to write the two half reactions, the oxidation, half reaction would be written, let me see, like hydrogen goes to hydrogen ion, okay? And then the reduction half reaction would be written platinum goes to platinum. And what you recognize here is when you write them just like this, there's two problems. Well, there's two problems with this one. One problem is that the mass is not balanced, and the other problem is the charge is not balanced in either one of them. Okay, so anytime you write a half reaction, you write down raw what you see out of the redox reaction, and then you have to balance it both in mass and in charge. And so in this case, we have hydrogen, two hydrogens, now we have two hydrogens, and the charge isn't balanced. The only way you can balance charge is with electrons, because electrons are what are moving around. So in the case of oxidation, which is loss of electrons, the hydrogen in this reaction, for the hydrogen, molecular hydrogen, diatomic hydrogen, is forming two hydrogen ions and giving off two electrons. In this case, the reduction reaction, I should have backed this up a little bit, this must be gaining two electrons. Okay, gaining two electrons, because it's going from a +4 to a +2. And then you can see when you add these two half reactions back together, you end up with 2 electrons plus platinum plus hydrogen to give hydrogen ion plus platinum plus 2 electrons. All right, and the electrons have been transferred from one species to another, and so because they show up on both sides, you just cancel them off because they're being transferred. It's not like you're creating them or losing them or whatever. They're moving, and this is how we show how they move. They originate here and they end up there. All right, and so this is the redox reaction, written as the net ionic reaction, and you can clearly see it's balanced in mass and charge. On the left-hand side, the total charge is +4, and on the right-hand side, the total charge is +2. Okay, so that's another skill, so you're not thrown when you see half reactions later on as we move along. And then I also showed you as I was showing you the half reactions, how we balance reactions. So look at this one. Is this particular equation balanced? 1 copper plus 1 silver gives 1 copper plus 1 silver. And at first glance, it does look balanced. But let's take a closer look. Let's write down the half reactions. First of all, the copper is going to copper 2+. So this must be going from a 0 oxidation state to a +2 oxidation state. So this is undergoing oxidation. The silver ion is going from a +1 to silver. It must be gaining electrons, so it's undergoing reduction. So our oxidation half reaction and our reduction half reactions, our oxidation is copper goes to copper 2+. The silver is going from silver plus to silver, and in this case it's obviously giving off 2 electrons, oxidation, loss of electrons. In this case, to balance out the charge, we add 1 electron to this side. And now if we were to add these two reactions back together to make the whole reaction, I mean, the mass is balanced, and the charge in this little half reaction is balanced, and the charge in this little half reaction is balanced. But the last thing you have to check before you add them two together is to make sure that the number of electrons that's being produced in the oxidation is the number of electrons that's being received in the reduction. In this case, it's giving off two, but this is only taking up one. So to truly balance it when we put it together, we're going to have to multiply this whole little half reaction by 2. That'll give us 2 electrons plus 2 silver ions, 2 silver. Okay, so then when you add them all together, you have the 2 electrons plus the 2 silver ion plus 1 copper gives copper 2 plus 2 silver plus 2 electrons. The electrons are balanced, the mass is balanced, and the whole thing is balanced. Okay, so that's a little example of balancing a simple little redox reaction. Recognizing that we write them as the half reactions. We look at individual half reactions to make sure the charge and the mass is balanced across the half. Then before we add them two together, we make sure that the electron transfer is going to be balanced. And in this case, we had to add that one more step to multiply the reduction by 2. Now, I want to tell you that in this class, we are just looking at some very basic oxidation reduction reactions. Oxidation reduction reactions, as you can imagine, can become more and more complicated, especially in aqueous solution, and which is the case for most oxidation reduction reactions. You know, if we're moving electrons around, we have to have ways to move electrons around, and so a lot of times we have things moving around. But anyway, to make a long story short, a lot of times oxidation reduction reactions occur in acidic solution or basic solution. And in those cases, sometimes the acid, base, or water, the hydroxide ion or the hydronium ion, can participate in the actual chemical change. And but in this class, we're not going to get into that. I just want you to be aware of it. For now, just understanding this basic concept that electron transfer does occur and can occur, recognizing this kind of unique way that we write these types of reactions in the form of the net ionic reaction, and just recognizing the very basic concept that electrons are being transferred is what I would like for you all to get out of this. If you go on and take chemistry, general chemistry in college, you'll get to do some more interesting things. And as long as you understand the basic concept, any steps you add on to that are trivial. Okay, one more thing I want to point out here at the end of this unit, and that is that you should be able to look at these half reactions. You should be able to look at half reactions, and you should be able to tell me whether or not each one of these half reactions is an oxidation half reaction or a reduction half reaction. And you should tell why. So this is just a little check yourself why. And I'd like for you guys to, now it's the end of this lecture, to go ahead and just take a look at this yourselves. And then before you do the next lecture, there's one more POGIL activity that I'd like for you to do, and that's called Introduction to Voltaic Cells. So once you've had a chance to talk about this with your neighbors and do a little bit of the homework associated with this lecture, then the next thing you're going to do is this Introduction to Voltaic Cells, which is a little group activity before you move on to lecture number 3.